Okay, today we will be doing January 2013. We will be going through January 2013. A good way to do this is to take the regions, work everything through yourself, and then follow me as I work them out with you. So in the first one, it gives you a graph. Now, you have all y equals here as your solutions. Since they were all y equals, you can absolutely just go through this and figure out which graph this made a graph of. And you'll be able to see that this is an exponential curve, and it fits this one right here. Your normal exponential curve goes this way. Notice they both pass through the point 0, 1. This one is your increasing one. This one is your decreasing one. Notice that negative x. When you do a transformation and you negate the x, here's your x, negating from here to here. This is a reflection over your y-axis. So that's why this one is your negative exponent. In number 2, here's a solution of ordered pairs. Now this one's a circle, and this one is a line. Your best bet is to solve this one for one of your variables and then plug it into the other one. So I'm going to solve this one for y, and we're going to get negative x plus 5. We're going to plug that in to this y and work it through. It's a little bit difficult with this one because of this. This is not a rational number, so you're not exactly hitting that any of those boxes at the right parts. So you're going to plug in your y. There's my y. Resolve this part right in here. This is going to become negative x plus 2. Then work those out. FOIL these both out. X squared plus 6x plus 9. And this one as well. Plus x squared minus 4x plus 4. Combine your like terms. 2x squared plus 2x plus 13. And then move the 53 over here, subtract 53, so that you build a trinomial that is factorable. Divide everything through by a 2 and make your life a lot easier. And then factor. We've got an x plus 5 and an x minus 4. So you've got an x equals 5 and an x, a negative 5, and an x equals 4. Now, take those and bring back your y. So your y was equal to negative x plus 5. Plug it into each one of these and see which point was there. So when you take x is 4 and you plug this in, then y is equal to 1. They gave you this point right here. That's as 1. When you plug it into this one, when negative 5 goes into here, this is going to become y is equal to negative 10. So here's your other point. And of those, they should give you one of these. So you look back to your choices, and oh, this was positive 10, of a negative, sorry. This was a positive 10. Be careful of your negative of a negative. So take this, and now here is your point. Negative 5, 10. And the easiest way to do that one. Use your systems of equations. Number 3 gives you a relationship between a student's test scores and their success in college. And they gave you this linear regression over here. This is based on your model for your linear regression model. this is no different than y equals mx plus b. There's your slope, your intercept. Now, they're looking for a correlation coefficient. When you do this in your calculator and you process your one-bear stat, you come down to do your linear regression. I think that's number 4 of your stat calc. Okay, when you come down to 4, you're going to get an R equals. This is your correlation coefficient. The correlation coefficient is between 0 is -1 to +1. 0 in the middle here. Now, -1 is a strong negative correlation. +1 is a strong positive correlation. Because this slope is positive, you want a strong positive correlation, and anywhere between the 0 and the 1. They just kind of made you think about that. See how there's your positive side. If this was my number line, from here to here is my correlation coefficient. And if it's positive, it's going to be between 0 and 1. In the next one, they're talking about a common ratio of a geometric sequence. Now, that tells you what am I multiplying by to get from here to here, from here to here, from here to here. Plug in the numbers that they gave you, and you will see that your answer is -2. When you multiply -2 times -2, you get 4. 4 times -2, -8. -8 times -2, 16. That's all they were asking for in that. Number 5, this goes along with your definition of what is a function. A function is a relation, a special relation, that every x has one and only one y. In other words, x cannot repeat. Know the definition of a function, of a one-to-one, and an onto. They usually ask one of those. So which one would be so that it is not a function? If any of these x's repeat, and therefore it would be 3. In number 6, you've got a negative exponent. A negative exponent, remember, flips it over. It takes the reciprocal. So I would work your negative exponent first, and I would take the reciprocal of this. Once you take the reciprocal, your negative is gone, and you've raised it to the positive. All that a negative does, 2 to the -1, says take this and flip this over to the +1. So now, you're going to use your rules and raise to the power. So we've got 1 over 9 to the 1/2, which is the square root of 9, x to the 1/2 times 2, which is 1, and y to the 6 times 1/2, which is 3. So the square root of 9 is 3x, y. And this is our cubed. So therefore, this one matches up to number 1. And number 7, this is a nice example of your standard deviation. You get this curve on your formula sheet. And when you work with the standard deviation curve, the zeros in the middle, the positives, and your formula sheet also goes by 1/2. So darken your 1, 2, 3 lines. It kind of makes it a little bit easier to go by 1, 2, and 3. In the middle is where you put your mean. So pull out your information. You have a mean of 153. And you have a standard deviation of 22. So work your chart. Put your mean in the middle. Add 22, and you get 175, and subtract 22, and you get 131. No need to go further than that, because they want your 68%, which if you added up your percents between -1 and +1, between there, it's 68.2%, between plus or minus 1 standard deviation. So those are the values that you're looking for. Number 8, your binomial expansion. Look for a pattern. I always say do a small one. This will show you what to expect. If the exponent is 2, notice we get 3 terms, so you always get one more. The first variable, this one here, is starting with the highest exponent and then reducing eventually to x0. So you can find your pattern here. So the 4th term for this is going to have 9 terms. You don't have to go out 9, but remember, they start with the 0. So you're going to start like this with your C's. This is 8, 0. This is 8, 1, 8, 2, 8, 3, 8, 4, and it continues. You want the 4th term. 1, 2, 3, 4. Right there. This is the one you want. Follow your pattern. Your first part of this is x. The second part is -2. Notice in this one, we started this one at the highest. So start at the highest. So x in this case would be 8, then 7, then 6, then 5. And this one would be your 3. These two have to add up to this number. Now this part you can put in your calculator. X to the 5th. This part you can put in your calculator. And then just multiply them out. Don't put the x in your calculator though. And that becomes your choice 3. In number 9, just remember to bring these down to the same base. We cannot bring 8 down to a base of 4. So we're going to drop both of these down to a 2. You're going to get 2 cubed raised to the 3k plus 4. And 2 squared raised to the 2k minus 1. Once you have the same base, you set your exponents equal to each other. So you're going to have your 3 times 3k plus 4 is equal to your 2 times 2k minus 1. And when you work that out, distribute, collect your like terms, you should be able to do the rest of that. You should be able to come out with k is equal to negative 14 over 5. Okay, the key here is make sure these go to the same base. And then your exponents are equal to each other. In number 10, this is a nice probability one. In number 10, they want to know how many different ways can you come in first, second, and third. It matters what order you place. So this is a permutation. Permutation says order matters. Combination says order doesn't matter. So permutation says you have n in your group, which is 8, or whichever you're looking at, that's your n. And you want 3 of them. Another way to do this is this way. 8, 7, 6. So this is your permutations, taking 8 things, 3 at a time. Number 11 is a nice problem of trig because they give you the double angle formulas on your formula sheet. And since they gave you the sine of the angle and you want the cosine of 2a, you're going to see 3 formulas for the cosine of a double angle. You want the one that contains the word sine. So we only want to use the one that already they gave us the information for. So write it out and then plug it in. Just take the sine out, put your sine in, and remember to square it. Now the rest you can put on your calculator, flip it back to a fraction, and you'll be able to come out with your answer. Number 12 is also a nice trig problem. Tangent, you can do one of 2 things. You can put this in your calculator and graph it and see that it's undefined. In other words, our asymptotes are going to be here at the 90 and the negative 90, and then again at the 270. You can remember your unit circle. And tangent is y over x. So whenever you divide by a 0, such as here, 1 over 0, undefined. Come through the axis here, and negative 1 over 0, also undefined. So you can see these are undefined at 90 and 270. Number 13 is talking about the domain, which are all possible x values that you can use, and the range, all possible y values. Well, you can certainly put this in your calculator and graph this, and you will see a graph that goes like this. You can find this piece here from negative 3 to positive 3, and that it actually goes up as high as 3. Another way to do this is to take this and to say we have a domain restriction. Anything under a radical that comes out has to be greater than or equal to 0. So if you take this and you set it greater than or equal to 0, remember, you're looking for the roots of this first. So x is plus or minus 3, and you're testing this. Now, a good way to test this is to plug this in your calculator. Notice that parabola goes down. Your negatives are down here, your positives up here, and your negatives here. We want the positive, which is this piece right in here. So therefore, your domain is negative 3 to positive 3. It's an and statement. So get rid of anything that's an or statement, and get rid of this guy. And there's your and statement right here. And your range was from 0 to 3.